Hi everyone, I'm Joe Flasher. I'm the AWS Open Geospatial Data Lead. So in that role, I talk to a lot of our customers around how they're using geospatial data in the cloud, both from groups that are trying to use it as data users, but then also as data providers. So I'm going to share with you today a little bit about what we're seeing around how geospatial data can be used for sustainable agriculture. So before I get too much into this, I just want to point out that this presentation will be mostly for groups trying to make use of the data. We also are very fortunate that we have a lot of data providers, groups providing satellite imagery mapping data in AWS, but this talk will mostly be focused on the users of that data rather than the data providers themselves. So if we look at a quick agenda here, I just want to go over what is the problem that we're looking at, right? What's the problem that customers are seeing in this space? Then we'll do a little bit of an overview of open data in AWS. We'll talk about how you can go about finding that data that is shared on AWS. And then my favorite part, we'll talk a bit about how users are making use of this data or putting the data to work. You'll probably hear me echo this again later in the talk, but it's one thing to make a whole lot of data available. But if that data isn't being used for anything, then there's really no point to it all. So I'm happy to sort of wrap up this presentation with that piece. So just to sort of set the stage, what is the problem that we're looking at anyways? It should come as no surprise that data is transforming the way that agriculture businesses innovate, right? Researchers, enterprises, developers are all looking to use massive amounts of data in new ways across new fields. I'm not saying anything super unique here. If you look at other fields like advertising, they've long used data to try and create more effective marketing campaigns. If you look at doctors, healthcare and life sciences fields, they've tried to use real world evidence from clinical trials to create more effective treatments, right? So nothing super new here, but we're going to focus on this in one specific field. So if we're thinking about agriculture, there's a whole lot of satellite imagery that's being made more available. More satellites are launching than ever, and that's projected to continue into the future. So there's more and more data coming from things like satellites, but also soils data, weather data, forecast data, but also climate data that's coming out. And you need to sort of put all of this data together to figure out things like, should I plant what type of crop? When should I plant it? When should I fertilize it, right? So all of this data, new data sources, and not even just new data sources, but more of the data sources that we've been used to are coming in, and customers are trying to make use of them. So this comes with an increasing acquisition cost, right? And I think when people think about trying to access large amounts of data, they often think of a licensing cost or a cost to purchase that data. But that's not the only cost. So certainly if you're talking about commercial or proprietary data, there is often a licensing fee. But that's not the only cost that you need to consider. Even if you consider valuable open source data that's freely available, there's still an acquisition cost in at least 2 or 3 other ways, right? So if you think about trying to work with large amounts of data, and large here can mean different things for different customers. So large for you could be 50 gigabytes of data. It could be a terabyte of data, 100 terabytes. It could be petabytes of data. We have customers that work across the whole scale. And I know this isn't the technical definition of big data, but to me, big data is whatever feels big to you, right? And so trying to store that data yourself can lead to an acquisition cost that you didn't necessarily intend, right? So if you're talking about terabytes of data or petabytes of data, trying to store that data can become costly. But also there's the time to acquisition, right? If we're talking about satellite imagery, if you've tried to purchase satellite imagery, you may have run into the paradigm where people will actually ship you disks, right? Or if you're trying to get open data from the government, sometimes you will ship them a disk, they will put the data on it, and then they will ship that disk back to you. It doesn't need to work that way in the cloud, right? By storing one copy of the data and having everyone work from that one copy of the data, you eliminate the need to pay or take the time to move that data around. Just as an example here, if we're talking about 1 terabyte of data, if you're trying to move 1 terabyte of data over sort of a normal network connection that most of us have, that can take around a day. That's a day that you aren't doing anything but moving bytes around, and that's a day that you can't even get to the part which you're trying to get to, which is actually doing something with the data, right? So there's acquisition costs that are beyond just what I think most people think about, which is just purely the licensing cost. But there's another acquisition cost that I think people don't think about often, and this is just an excerpt from a book by DJ Patil and Hilary Mason, which matches very closely with what we hear from a lot of our customers, which is oftentimes a lot of the work comes not just in trying to get access to the data, but trying to clean up the data to get to the point where you can ask the questions of the data that you want, right? And there's a number here. I've seen 70%, they say 80%, but it's a lot, right? No matter what the number is, it shouldn't be that high, because this is work being done to get to the point where you can do work. Amazon has this concept of undifferentiated heavy lifting, where we can remove tasks that customers are doing over and over and over again. We can add value, right? And so when there are the same similar tasks that are being done over and over again, if we can take that out from having our customers having to do that, we consider that removing undifferentiated heavy lifting. And a lot of this 80% number is coming in undifferentiated heavy lifting. So I want to talk a little bit about open data in AWS and how we think about it. I am on the open data team, and we oversee the open data program. And we believe that sharing data in the cloud lets more users spend more time on data analysis rather than data acquisition. And so we do that through things like trying to remove undifferentiated heavy lifting, making it so that users don't have to download the data, but can instead work on a single trusted source of the data. You can find more information by going to opendata.aws, and I'll also bring up the registry of open data, which is how most of this data gets exposed, a little bit later in the talk. So I wanted to go over some advantages of sharing data in the cloud. So the first that I want to talk about is the global community of users. When data sets are pulled down locally or pulled down somewhere else where they're siloed from a larger group of users, any additions or updates or fixes to that data set, there's not often an incentive to get them shared back to the source of the data set. When data sets are shared globally and everyone works on top of the same copy of the data set, any changes that are made to the data set are then available for all users of that data set. So I like to say that siloed data sets lead to siloed communities, whereas shared global data sets can lead to shared global communities. The other piece here is that when you share the data or working with data shared in a public cloud, you get the advantage of the pace of innovation. So you get to take advantage of all the new services and tools that are coming along. So this is a double-edged sword in some cases, especially when we talk about new services. You may have done a lot of architecting around the current service offering, and then a new service comes out and you think, oh, that is perfect for what we're trying to do. This often happens. And then you need to make the decision, do you want to keep with your current architecture or do you want to re-architect for the new service? So it can be a pro and con. Long term, it's obviously a good thing. Short term, it can present a little bit of pain. The other one, though, that I actually find very interesting is when new features come out to services that you're already using. Keep in mind, you're working alongside all of the other users in the cloud, and so there are other customers that are asking for features that you might not even have thought of or knew that you needed. So one of my favorite examples of this was when overnight, the request rate for our object store, Amazon S3, went up by about an order of a magnitude. So if you were using S3 to work with your data, overnight to you, it certainly wasn't overnight for the engineering team, but to you as a customer, you just woke up to a notice that said, hey, it can now work with request rates up to about an order of magnitude greater. That obviously changes fundamentally how our customers can build their architectures and is a super great example of how the pace of innovation works for you as a customer of the data. The other two that I have here around faster pace of research and lower cost of research are really just talking about how it takes you getting rid of those acquisition issues that we talked about earlier, right? Storing copy of the data, or even having to have large compute assets around to work with the data. Of course, don't forget that one of the advantages of the cloud is that you only pay for what you use. So if you have compute resources that you're only using for a certain period of time, you're only paying them for a certain period of time. And all of this lets you work faster. So I want to dig in a little bit around that global community of users example and talk about a geospatial specific example, which is the cloud optimized GeoTIFF. So if you've worked with satellite imagery before, you've likely seen the GeoTIFF file format. It's very common for raster data, which most satellite imagery is. And typically in the traditional paradigm, when you would work with this data and you would try to get access to it, you would often need to get large archives of the data that were bundled up in sort of archival formats, often for legacy tape reasons, for storage on tape. And so to put this into a practical example for agriculture, if you only wanted, say, 2 bands of satellite imagery over a field because you wanted to do like an NDVI or crop health sort of analysis. This is sort of a typical thing we see in agriculture. It has sort of become the hello world of agricultural programming, I think. But if you're trying to do that, you often, in sort of the traditional mechanism, would need to get access to 1, 2, 3 gigabytes of data. But what you really want is only the few hundred kilobytes of data that surround your field for those two bands. But because the file formats were sort of archived, you would need to get all that data. When we worked with customers to make petabytes of Landsat data initially available on AWS, we said, what are your pain points for working with the data and how can we sort of work around them, right? How can we remove that undifferentiated heavy lifting that we're seeing a lot of customers have to do? And so we worked with customers to unarchive the data. We did some other internal tweaks to the data that sort of are outside the scope of this talk. But basically, that became known as the cloud optimized GeoTIFF. That's the data that's made available in S3 now if you go to access Landsat imagery. And there's a number of other satellite imagery data providers that have started using this format as well. The key thing here to bring it back to the practical example is now, if you just want your field boundary and you only want the 2 bands, you can request just the 100 kilobytes of data that is, rather than the gigabytes of data that you don't want. So when we talk about cloud optimized data, I don't know that it really has a technical definition because it's more of a general concept, but I like to think of it as getting access to just the bytes that you do need with the minimal amount of bytes that you don't need. Obviously, having to transfer less data means that processes can run much quicker and they're cheaper to run, right? You're just transferring less data across a network. And so that work was done by a global community of users, and the changes were made to the sort of source of the data, right? So this wasn't work that was done by one company and only the advantages were seen by one company. It was done by a global community of users, and the advantages were seen by the whole community. You can see a lot of tools, libraries, programs now take advantage of the cloud optimized GeoTIFF to work with satellite imagery in the cloud in a much more performant manner. So I talked a little bit about the Open Data program, the registry of open data, which we'll see again later. But there are other ways to get access to open data, as well as other data that you might be looking to work with for your processes. So AWS Data Exchange is a way to easily find, subscribe, use third-party data available in the cloud. There's a whole piece here for data providers, but again, I'm going to focus just on data subscribers for the purpose of this talk. And as a data subscriber, you can go through a catalog. You can find different sources that you're looking for. There are free data sources available through AWS Data Exchange, but the other thing that might be of interest to you is that there are also commercial data sources available through Data Exchange. So it is a marketplace offering, so it makes it very easy for you to pay for data sources when that's within your business interest, right? If that's what you're looking to do, is pay for certain commercial data sources. AWS Data Exchange makes it easy for you to do that and have that data show up in your account so that you can use it. And the big thing that I want to sort of drive home here is that from a technical perspective, if you're working with open data available in a federal agency's bucket that's being made available on AWS, and then you're working with commercial data that you have purchased or have a license for that are also being made available on AWS, and then you're trying to work with your proprietary data that you also have in the cloud in AWS, technically speaking, as long as you have access to those different S3 buckets, your code doesn't know a difference, right? You're not seeing higher latency access to the different data sets. These things are all sort of logically together in the same space. And so you get the same low latency access from your processing compute resources to all of these different data sets. And so again, you can work with open data alongside commercial data, alongside your proprietary data, all at the same time. And just to sort of drive home this point that I've sort of been saying implicitly, but I want to make explicit, the traditional approach generally revolved around taking your data to the compute resources, right? Like you would take a disk and you would show up somewhere and you would do the work alongside compute resources. But here the model's flipped, right? It's hard to move around large amounts of data, and there's other reasons why you wouldn't want to do so. It just incurs time. It also incurs a need to synchronize data if you have it duplicated in multiple places. So it's better for a lot of data sets to leave them where they are, and then it's very easy to attach compute resources from various different types of services, whether you're doing things that look like SQL queries, or you're trying to do like virtual desktops or virtual computers, right? Like there's a whole wide variety of different types of services that you can can run on top of the data in place where it is without having to duplicate or move it around. And that's the more cloudy way to sort of work with data at scale. So altogether, when you look at the services that are offered on AWS, and you're looking at storing your data in a scalable mechanism like Amazon S3, you see that there are a ton of services that can be used on top of that data. And all those services are just different views into the data. So here I just have an example of sort of our AI ML offering Slate, right? And this is only one sort of specific piece of our offering, our total offerings, right? And so you would see something that looks like this slide for different types of pieces of those offerings. And the point that I want to drive home here is not that you should look at every different service on here and think exactly what it does, but you're storing the data in a way, hopefully a cloud optimized way, that can be easily used by across a whole plethora of services without having to duplicate the data storage into proprietary formats for all these different services, right? So store the data once and work on top of it in the cloud. So I hope I've sort of given you an idea of why you might want to have your data in the cloud, why you might want to work with shared data, open data in the cloud. I want to now give you some info on how you can go about finding that data, right? And we'll cover the two different mechanisms that we already talked about, which is the registry of open data on AWS and the AWS Data Exchange. So I'll start with the registry of open data. You can find it by going to registry.opendata.aws. And this is a catalog listing of a bunch of open data sets that are available on AWS for you to use. This is not a selling channel, right? So this is different from AWS Data Exchange. So all of these data sets are freely available. And I want to dig in a little bit into how simple it is to get started with these data sets, right? So you can search the catalog by different tags like agricultural, satellite imagery. We'll dig into a satellite imagery source that'll come up later in some of our examples. This is Sentinel-2. So this is a Copernicus Sentinel satellite. It's about 10-meter optical imagery. And so when you go to the dataset landing page, you'll actually find the different resources that are listed out for it. Right now, I'm just going to focus on the S3 bucket. S3 has already come up a number of times as our object store. And so the satellite imagery is stored in that S3 bucket. You can see that the resource is listed there. Like I said before, there are a number of tools and applications that take advantage of S3 access. So you can likely use this S3 endpoint in a lot of the tools you already use. But you can also take advantage of the AWS command line interface to just start working with the data directly. So the last little piece there in the dataset listing is the command line interface line. So we'll copy that out. And if we just pasted that into our terminal and we do something that lists the bucket contents, you can see here that we just start listing the contents. So I don't even need an AWS account to do this. Most of these data sets you can access without an AWS account. You can do it anonymously. And so you can see that you can work with the data directly without any sort of complicated interfaces in between you, right? If you wanted to grab one of these satellite images, you can go ahead and do so directly. So it's very easy to get started working with the data almost immediately. And like I said before, there are a whole host of tools and applications that you can find. And in fact, the Registry of Open Data lists just over 500 tools, applications, publications on all the different data sets about how they are being used by different customers. I sort of said this at the outset, but part of my job is to make sure that we have a lot of data that customers are looking to use in the cloud. And that's very cool. But if nobody's using that data, then we're not really doing our job well, right? Like, what's the point if nobody's using it? So part of what I do is try to focus on helping others figure out how customers are making use of this data and surfacing reusable assets to make it as easy as possible for you to use this data. So if we think about the Registry of Open Data and we want to bring it back to an agricultural focus, what are the different types of data sets that are in there that might be of use for you? Well, of course, there's a ton of different agricultural use cases. So a lot of these data sets are going to be very dependent on your use case. If we just think of some of them, though, if we're thinking about temperature, weather forecasting, solar units, those sorts of things, if that's of interest for you, we've got NEXRAD, which is our U.S. Meteorological Agency's radar data, weather forecast radar data. We also have climate forecasts, weather forecasts from a number of different national agencies around the world. So Australia's there with Silo, Meteo France, the UK Met Office, at our U.S. Meteorological Agency as well. We've got soil-related data sets or topography-related data sets if you're looking for things like water runoff. African soil information data is there. Terrain tiles data set is actually a very cool data set. It's a derived data set. So it's actually best at pixel elevation for bringing in a whole bunch of different elevation data sets. So that's a very cool one as well. If you're looking at sort of growing conditions, yield potential, these are a lot of satellite imagery data sets. So Sentinel-2 I already mentioned. Sentinel-1, which will come up in a bit in one of our customer examples, that is actually radar data. Whereas Sentinel-2 is optical data mostly. There's things like the Chinese-Brazilian satellite data set, Landsat-8 from the U.S. Geological Survey, and then GOES, which is a geostationary satellite. So there's two of them positioned over the east and west coast of the U.S., whereas the other ones are sort of normally orbiting satellites. If you're looking at impact of natural events, certainly flooding would potentially affect what you're doing. Wildfires, of course, as well, unfortunately. We have customers like Maxar who are making their data for natural disaster response available in AWS. And so this is high resolution commercial data. So whereas previously some of the satellite data I was talking about was sort of 10 meter to 30 meter, Maxar data is more in the order of 0.5 meter to 1 meter. And this is data that they make available for free for natural disaster response scenarios, right? So you can find that there as well. And of course, if you're looking for things like harvest timing and you can detect this from satellites, the same set of satellites would likely be of use to you as well. So there's many more data sets there. And in fact, one of the coolest things I think is when you find a way to use a data set other than its intended purpose, right? Like this is amazing, and we've seen some really cool stories come out around doing this for various data sets. So don't feel limited to just this slide. Please go check the Registry of Open Data, and you'll find a number of data sets there to play around with. So I also wanted to mention AWS Data Exchange. It has a similar catalog. You can sort by free. You can look for things that are relevant to the agricultural domain. So keep in mind here that you're not just looking at free data, but you're also looking at data that can be licensed. So you will find commercial data sources on here. Of course, not every data set should be free or is free. So if you're looking for things that have a license fee or commercialized, AWS Data Exchange will be the best place to look for there. And you can sign up, pay for, and subscribe to the data sets and then get access to them from within your account. So sort of trying to bring some of this together, I wanted to talk about how some of our customers are putting this data to work, because after all, that's sort of one of the most important pieces. So the first one I wanted to start with was a customer called OneSoil. And so OneSoil is super cool. They're out of Minsk, and they actually were doing a lot of this work by hand. So they would have farmers call them and say, hey, like I want to know when I should plant. How's my fertilizer distribution going? Do I need to do it differently? They would take the images and do the analysis by hand. They obviously realized this wouldn't scale as they grow their business, so they switched to using global satellite imagery, and they're now able to monitor around 60 million fields across Europe and the US, right? And the cool thing is, what I love seeing is big changes in what's possible. And they went from doing something that would take them about 50 years to do by hand, and they were able to do it sort of at scale on a regular basis now, right? So that's obviously a step change for their business. The other cool thing about OneSoil is they're able to be much more responsive now, right? And so they're able to get answers to the questions that they're looking for within around 5 days. And you can imagine if you're trying to plant or change your fertilizer distribution, the speed at which you know those answers is critically important. So they've cut that down to about 5 days, which lets them be much more responsive to their downstream customers. So other than growing up smelling a whole lot of manure, I'm not a farmer myself. I've not been ever super connected to the agriculture industry, but I would have to imagine that access to water is one of the key critical components that you're looking for when you're thinking about agriculture. So there's a group, Blue Dot Observatory, who actually went and did global water body monitoring, and they're able to monitor around 7,000 water bodies around the world on a regular basis as new satellite imagery comes in. So they're using Sentinel-2 data to do this. So this is the Copernicus Sentinel data, optical imagery around 10 meters. As new imagery comes in, they say, hey, programmatically, they can say, hey, does this data match one of the water bodies we're looking at? If it does, then they'll run a process to figure out what's water and what's not water. And you can see from the image there, this is actually from around Cape Town when they had their drought issues previously. And you can see, unfortunately, the water is just sort of disappearing in the imagery, right? So one of the things that I want to sort of hit home on this slide, though, and it's a very big point, is that I think when I talk about big data, when I talk about using lots of compute power, I think a lot of times people equate this with costing a lot of money. But it doesn't need to, right? So if you're working on top of data that's already shared and you don't need to duplicate that data storage, and you can use just the compute you need to answer your question, you can do this very economically. And so as an example here, Blue Dot Observatory monitors these 7,000 bodies of water globally. They do that for about €6 a month, right? Like that's amazing. So I just want to call that out, right? Oftentimes people think big data, big compute power, big money, but it doesn't need to be that. There are ways that you can do this on a shoestring budget, and we are more than happy to help you figure out how. I also want to call out initiatives like Digital Earth Africa that we're proud to be supporting. So we're happy to be a tech enabler for Digital Earth Africa. So Digital Earth Africa is an initiative that's bringing satellite imagery, weather forecast data, over Africa and making it available within Africa, along with compute resources for the African continent, right? A lot of the issues that they're going to be looking at are things like drought, food security, and they're going to be doing that on top of data from global data sets, but made available in the Cape Town region. That's a relatively new region for us, along with, and then it'll be computed on compute resources happening within Cape Town as well. So this is really meant to be an initiative and a resource for the African continent as a whole. The interesting thing here about Digital Earth Africa that I also want to mention is that Digital Earth Africa is actually sort of a second iteration of a previous project called Digital Earth Australia that is still running. This project's being run by Geoscience Australia. Geoscience Australia built that platform in part on AWS and using data on AWS. And so when they wanted to shift it over to the Cape Town region to use data in Africa and resources in Africa, it was easier for them to do so. So it was a project that was built in the cloud, and then they were able to move it to different parts of the world to meet different global demands. So that's, I think that sort of reusable component aspect is a phenomenal aspect of the cloud as well. And then I just want to point out that sort of the examples that I gave before are often sort of script-based. So you go into command line interface, you do something, you write an algorithm, you put it into a service, and then it runs against things. And this is going to be a traditional way of operating for a number of our customers, but for a number of our other customers, they're actually going to be more interested in working with their GUI-based desktop applications. And so that's totally possible as well. We see customers like Sinergise here making services, for example here, Sentinel Hub, that will give you those standard sort of interfaces that your desktop applications will be looking for. And so what you can do is you can either run those desktop applications locally like you might be used to. The only thing is you're going to be pulling data out of the cloud then, right, when you're sort of working with these interfaces, which is fine. But it's going to be a little lower latency, higher latency access to the data, right, because you're sort of pulling it out of the cloud. But what you can also do is use virtual desktops through services like Workspaces, and you can actually run those same desktop applications. So you get your GUI sort of interface, but you can run them right next to the data in the cloud. And so then your sort of big data access piece is still happening in the cloud, and all you see is the traditional remote desktop pitch, which is you just see the pixels refreshing on the screen, right? So you still get the super low latency access to the data. You get compute resources that you're looking for that those sort of GUI applications can run on. You get the tooling that you're used to, and then you just sort of get to interact with them in a traditional remote desktop environment. And so everything I sort of said previously about the non-siloed data sets, all of that sort of stuff still applies here, and you can still use your traditional desktop applications. So I just want to close by leaving you with some resources that may be helpful if you're looking to learn more. First is go find the data, go search for the data that you're looking for. The Registry of Open Data on AWS, AWS Data Exchange will be two great places to go find that data. You can always hear from others about how they're using geospatial data on AWS. You can go to the Earth on AWS page, so the link is there. But we look to highlight stories and tutorials coming from users of the data on AWS to help you hear from them directly about what they're doing. You can also find a number of tutorials, applications, publications of how people are using the open data on the Registry of Open Data on AWS. And finally, you can take advantage of free AWS training. One that might be of interest for you if you're attending this session is the Satellite Image Classification in SageMaker tutorial. And again, this is a free tutorial that you can take advantage of on the AWS training site. With that, I will just say thank you, and I hope this has been helpful and been insightful. And please remember to complete the session survey that will be sent to you.